Welcome back to the next lecture. Today we're going to be talking about what it means for a number to be to the left of 0, what it means for a number to be to the right of 0, and the relationship that these have with each other. We've kind of already covered this in previous lectures where we've used some of these properties, but let's go ahead and write them out and formalize them. So we're going to do a little bit of mathematical modeling today, which is always an exciting thing to do. Let's go ahead and start with a simple-ish problem, which is 5 plus negative 3. I want to start by doing this on the number line, but then we're going to introduce some new kind of modeling that we can do. So 5 plus negative 3. Here's negative 3. Here's 5. Let's see if I can draw this well. Negative 2, negative 1, 0, 1, 2, 3, 4. Yeah, it's a little more bunched up on the right. Pretend these are evenly spaced. So what 5 means is to step to the right of 0 5 paces. And then whenever we say plus, we're saying at the end of what we did previously, do something else. So 5 plus negative 3, well, 3 just means 3 in the left direction, right? So it means this, 3 in the left direction. So if we take the tail of that and put it to the tip of the previous one that we did, so we already took 5 paces to the right. Now we're going to take 1, 2, 3 paces to the left. We end up with, and I'll use blue here, we'll end up with a number, which is 2. So this is visually what we're doing whenever we say 5 plus negative 3 is 2. We're saying that, and let me get rid of this here, we're saying that if we go over 5 and then to the left 3, we're going to get to 2. And let me get rid of it. This isn't 5 plus or minus if you're familiar with that notation. I was just underlining it. So let's do another one. Let's do a simple one, probably one we should have started with. Let's do 2 plus 3. So all of these are going to be to the right of 0. So 1, 2, 3, 4, 5. 2 plus 3, we all know, hopefully, we all know that it's 5. What this really means is 2 to the right, and then picking up from where we left off, 3 more to the right. So 1, 2, 3. So we went 1, 2, and then we went, I don't even know how that did that. We went 1, 2, which is what this 2 represents, and then we went 1, 2, 3, which is what this 3 represents. And we ended up with 5. So this is what we mean whenever we say 2 plus 3 is 5. Where it means go to the right 2, go to the right 3, you end up with 5. Let's do another one that may not be as obvious. Let's do 4 plus negative 1. What does that equal? 0, 1, 2, 3, 4. So we have to go to the right 4. So 1, 2, 3, 4. And then from there we have to go to the left 1 is what that means, right? We have to go the opposite of going to the right 1. So we have to go to the left 1. We end up at 3. One more, which again may not be completely obvious, is 2 minus 3. We have a little bit of translation to do now whenever we're working these, because we haven't really defined what the subtraction operation is or what minus means. But all this is saying is 2 plus negative 3. These are exactly the same thing. If we have x minus y, that is equal to x plus negative y. Again, as I've mentioned, I think in almost every video so far, I prefer this notation because I think it's a whole lot more clear about what's happening. But this notation is something that is, this is how people in everyday life is going to write it. You have $5 in your bank account. You take away $3 from your bank account. How much you have? Okay. So we know that 2 minus 3 is 2 plus negative 3. So now we're going to get our number line out. We have 1, 2, negative 1, negative 2. First thing we do, go to the right 2, 1, 2. And then the next thing we do is go to the left by 3, right? That minus sign means go to the left. So from there we go 1, 2, 3, negative 1. So 2 minus 3 is equal to 2 plus negative 3, as we said before, which is the opposite of 1. It's all that means is if you go to the right 2 and then to the left negative 3, to the left 3, that's the same thing as going to the right, or to the left negative 1. Let me say that again because I butchered it. Going to the right 2 and then going to the left 3 is the exact same thing as just going to the left 1. Hopefully that makes sense. We'll do one more before we get to the kind of different way of looking at this. I just prefer to start with the number line. And we're just going to take this and flip it on its head and say negative 3 plus 2. What is that? So we're going to start negative 3, negative 2, negative 1, 0, 1, 2, negative 3, negative 2, negative 1, 0, 1, 2. We're going to go to the left 3 is what this means, right? The opposite of 3. So we're going to go 1, 2, 3. And then we're going to go to the right 2. 1, 2. Just as we said before, it's negative 1. So, and this should make sense, right? Because one of the properties of addition is that x plus y is equal to y plus x, which is called, by the way, commutativity of addition. If we have 2 plus negative 3, we would expect that to be the same thing as negative 3 plus 2, and in fact, they were both negative 1. So it all works out. Okay, the other way that I would like to present this, or to kind of show you a little bit of modeling what you would be doing, I think, in the lecture, is kind of these ideas of counters and anti-counters. I imagine these as like those counter chips, those circle counter chips. So let's do 5 plus negative 3. What 5 means is you have 5 of something. So we're going to model this with the counter chips. You have 5 little chips. And what this negative 3 means is we also have anti-chips. So if you're familiar with from like physics, matter and antimatter, or anything like that, you have the opposite of, the inverse of something. So we have 3 anti-chips. And 1 positive chip and 1 negative chip cancel out. And they make 0. So this annihilates to 0. This annihilates to 0. This annihilates to 0. How many chips do we have? We have 2 positive chips, and so that's how we get positive 2. Let's do one more with this method. Let's do 3 plus negative 5. Or 3 minus 5, again, whichever way you want to put that. So we have 3 regular chips, and we have 3 anti-chips. 5 anti-chips. And so each positive chip and negative chip cancels out to 0. So this makes 0, this makes 0, this makes 0. We're left with 2 negative chips, 2 anti-chips, meaning negative 2. Okay, one more thing to talk about for this lecture, and that is essentially plugging things in. As I think we've discussed in a previous lecture, we can have something like x plus y squared when x is something and y is something, right? And the way we would do that is plug whatever x is into x, whatever y is into y, use the order of operations to simplify. So let's say here x is negative 18, because now we're not going to just do positive numbers, we're going to do negative numbers as well. So let's say x is negative 18, and we have y is going to be, let's do 14. Well, so let's go ahead and plug everything in. Let's rewrite it. X plus y squared, plug in x is negative 18, plug in y, you get 14 squared. Now, if you remember PEMDAS, which we talked about previously and hopefully you've had some exposure to, you do what's inside of parentheses first. So we're going to do this first. So negative 18 plus 14, if you imagine 5, 10, 15, here's 18. So we're going to go negative 18, or we're going to go 18 to the left, and then we're going to go 14 back this way. What are we left with? Well, let's see. So this distance here is 3 from negative 15, negative 10, negative 5. So we go that distance of 3, and then we do 10 more, 13, and then one more on this side is negative 4. So negative 18, plus 14, which is x plus y squared, is going to be negative 4 squared. And remember, squared means, and I've actually run out of room a little bit. Let's go ahead and go to the next page. We got negative 4 squared. What squared means, if we have like x squared, is x times x. If we had x cubed, it would be x times itself 3 times. Something to the 4th power is x times x times x times x, for example. So we got 2, 3, 4, right, and you can see the pattern. So negative 4 squared is going to be negative 4 times negative 4. And whenever we multiply these, as we'll see in a little bit, I think lecture 2.3, which is the next lecture, negative 4 times negative 4, those negatives are going to kind of say the opposite of, which in reality is doing nothing. If you remember, the opposite of a number is going to be just that number. So it's going to be 4 times 4, which is 16. And we'll come back to this in the next lecture. So overall, x plus y squared, when x is negative 18 and y is, 14? That is going to be equal to 16. Okay, and I think that's going to wrap it up for this lecture. If you have any questions or any thoughts on this and you want to talk through it, feel free to send me an email and we'll absolutely do that. All right, see you